In section 2, we're going to start getting into more stuff about lines. And the first thing that we'll look at is finding slope of lines, or slope between 2 points. So the title of this section is Slope and Rate of Change. We won't really talk about rate of change too much. I guess the difference between slope and rate of change is a rate of change is what you could call a slope if it's comparing two different units. So like if you have a change in distance over a change in time, that's a rate of change because it's two different units. Now if you compared two things, one over the other, that were the same unit, so miles over miles, if I traveled some distance and you traveled some distance, and we compared those, then that's just a slope. But it's a rate of change if the units are different. So like miles per hour, or a wage of dollars per hour, things like that would be considered a rate of change. So there's a handful of ways to describe slope, which you may recall. We used the letter M to represent slope. I couldn't really tell you why that is. But slope, we've also maybe heard or considered it to be rise over run. And then I bet that the slope formula here is familiar. And we could write it a couple different ways. So the slope between 2 points is y2 minus y1 over x2 minus x1. So the y-coordinate minus a y-coordinate over an x-coordinate minus an x-coordinate. You could also flip those around and do y1 minus y2 over x1 minus x2. It's really the same because nobody says which point you have to designate as point 1 and point 2. And so you could flip them around and you're fine, as long as you do the subtraction in the same order. So let's look at the example right here where we're asked to find the slope between the points -4, -5, and 6, -2. So we do, let's just call this one point 1, the first one. So this is x1 and x2. Sorry, not x2. X1 and y1, and then x2 and y2. And I'm going to do y2 minus y1. So we're going to do -2 minus a -5, and then over, and we just have to make sure that we subtract the same order. So we have to do 6 minus the -4. And we could have gone the other way. We could have done -5 minus the -2, and that'll work out as long as we do -4 minus that positive 6. So we just have to subtract the same direction both times. So -2 minus a -5, -2 plus 5 is going to be 3, and then 6 minus a -4, so 6 plus 4 is going to be 10, so our slope here is 3 over 10. So then when it comes to describing slope, there are 4 different types of slope. If we have a line that goes up and to the right, that is a positive slope. If we have a line going from left to right going down, that is a negative slope. If we have a line that is horizontal, so, well, one, we could describe it as horizontal, but then what's the slope of that? In this case, the slope is 0. There's no rise while it has a run, so it's 0. Some people will say that that's no slope, and I don't know that I'm a fan of that, because it does have a slope. Its value is 0. That doesn't mean there's no slope and we can't describe what it is. It does have a slope. Its slope is 0. So I don't like the phrase no slope, so try to use horizontal or 0. And then we could have a vertical line, which again we could describe as vertical. And the slope of a vertical line is undefined. The reason for that is here the x-coordinates would be the same on a vertical line. And so when we do our subtraction, we end up with a number, and if the x-coordinates are the same, we would have a 0 on the bottom of our fraction, which we can't do. We can't divide by 0, so that is undefined. We can describe parallel and perpendicular slopes. So two lines are parallel if what is true about their slopes. Two lines are parallel if they have the same slope. And that's easy to tell. If one line has a slope of 2, then any other line with a slope of 2 is parallel to that line. Slopes are perpendicular if they are opposite reciprocals. So in math, opposite means the opposite sign. So the opposite of a positive is negative, opposite of a negative is positive. And then remember that reciprocal is, so like if we have A over B, the reciprocal of that is B over A. So if we have a slope of 3/4, then the perpendicular slope is a negative 4 over 3, so negative 4/3. Or if we have a slope of negative 5, the perpendicular slope is the opposite of that, so a positive, and this would be 5 over 1, so 1 over 5. Okay. So looking at this problem here, are the lines between the following pairs of points parallel, perpendicular, or neither? So first we need to find the slope between the first 2 points, find the slope between the second 2 points, and then decide are those slopes parallel, perpendicular, or neither. So setting up with the first one, I'm going to do 5 minus 4 over 2 minus that negative 1. That gives us 1 over 3. So our slope there is 1/3. For our second pair of points, I'll go 4 minus 2 over 0 minus that negative 6, which gives us 2 over a positive 6, which is 1/3. So our slopes are the same, so these two lines are parallel. One more example for a type of problem that I think I might have you doing on the homework. Find a k. So we're given a slope and we're given 2 points, except a coordinate's missing. So we want to find the coordinate that would give us that slope. So basically, just into the slope formula, just plug in everything we know. We know that the slope is 1. We could say y2 is 4, and y1 would be k over x2 would be 3, x1 would be 0. So plug in the things we know, and I'll let you go from there, and all you have to do is solve for k, and that will give you the coordinate that would give us the slope of 1 between those points.